Here we're going to talk about application lifecycle, and there's three prerequisite concepts before we really get into it. That's single instance, suspension, and termination. You can only have one instance of a UWP app running at a time. Suppose the user launches your application and your onLaunched method runs, of course, and then while your application is still running, they go to the start menu and they tap on your app's tile. You do not get a second instance started. Instead, the onLaunched method runs again inside the already running application. Windows 10 runs on a lot of different devices. The goal is to provide a great user experience on every device, and to do that, Windows tries to give all the CPU time it can to the app the user is actively working with. Any other UWP apps that the user is not working with may be suspended, which means they're still in memory, but they're no longer receiving CPU time. That'll make more cycles available to the active app. The trigger that causes an app to become eligible for suspension differs by device. On the desktop, if the user minimizes the app or locks the screen. On the phone, if the user switches to a different app or goes to the home screen, again, the inactive app becomes eligible for suspension. The end of an application's lifecycle is also interesting. Once an app's suspended, remember, it's no longer receiving CPU time, but it is still in memory. Memory is another resource that Windows may need. If Windows decides that it needs to reclaim that memory, it may terminate any and all suspended apps. So imagine the user is working with this app here, they minimize it, which means they're no longer interacting with it, it becomes eligible for suspension. Windows may choose to suspend it, and then later, Windows may choose to terminate that application. So this is a case where Windows, rather than a user action, is the direct cause of the end of an application's lifecycle. Of course, the user can also terminate an application. They can click on the close button there. There's a keyboard shortcut and even a gesture for touch devices. So we've just seen two different ways that an app's lifecycle can come to an end. It might get suspended and then terminated by Windows, or the user may choose to close it themselves. In all cases, Windows remembers what happened. So Windows knows how an app's lifecycle came to an end. It stores that information and then passes it to the application the next time it runs. And that shows up in the event arg. So here's the onLaunched method. Notice it has launch activated event args. Inside there is something called previous execution state. That's an enum. You can see all the values listed right here. And we just talked about two here, terminated and closed by user. Here's a quick explanation of what action by either the user or Windows can generate each of the 5 different states. If you want all the details of how these can happen, there's a link to the documentation. To see how previous execution state works, let's run some code. Here I have a simple app. This is the easiest app I could think of to demonstrate the idea. This is the entire application here. Our app class with our onLaunched method, the event args right here will contain previous execution state. We just convert that into a string and then load that string here into a text block. Then we put the text block as the Windows content. Remember, content is a UI element. Anything that we put in there is what the user will see, and then we call activate. Our goal is to run this several times to generate each one of these states. This is the first time we're running the app. It's not currently installed. We're going to get not running as the previous execution state. I'm going to close it using the close button. Then I'm going to run it again. This time we're going to get closed by user as the previous state. Now, while the app's still running, I'm going to go to my start menu here, locate the tile. There it is, previous execution state demo. And I'm going to tap the tile here in the start menu. We did not get a second instance of the app. If we look at Task Manager, we can see there's only a single instance running. But what did happen is we re-executed the onLaunched method of the already running app, and this time the previous execution state was running. Now, without closing the app, I'm going to go back to Visual Studio. The Lifecycle events drop down here lets us simulate suspend, resume, and suspend and terminate. Let's do suspend first. The app is now suspended, which means it's in memory still, but it's no longer receiving CPU time. If I go to my start menu here, again locate its tile and tap on it, we run through the onLaunched method again of the suspended app. This time, of course, the previous execution state is suspended. Now again, without shutting down the app, I'm going to come over to Visual Studio and do suspend and terminate. This time when I run it, the previous execution state will be terminated. Let's do one more case. Suppose I bring up Task Manager here, and I use Task Manager to kill the app. This time when I run it, we're going to get not running as the state.